Welcome our viewers to today's presentation, and welcome to Kenya's #1 premier educational center channel, KUTV. Your teacher John Otieno, and today we will be looking at the topic of linear motion. That is a Form 2 topic on linear motion, and specifically we will look at the subtopic of relative speed. However, we'll do a few introductions before we go to relative speed. We'll have a few definitions that will introduce us to the topic of relative speed. Now, first of all, we want to give a brief definition of what linear motion is. Now, linear motion is a change in position from one point to another in a straight line in one dimension. For example, if we have a point A and a point B, now the change in position from point A to point B is what we call linear motion. For example, if a car is driven in a straight line from point A to point B, then we say that is a linear motion. In linear motion, there are a few definitions that we want to look at. We look at the definition of distance, speed, displacement, acceleration, and velocity. Now, distance is just the length between 2 points. Length between 2 points, it's what we call the distance. For example, the length from point A to point B is what we call the distance. Another definition that you want to look at is displacement. Now, displacement is just the distance in a specific direction. This is distance in a specific direction. For example, if a particle moves from point A to point B, then we say that the particle is displaced from point A to point B. The next definition that we want to look at is speed. Now, speed is the rate of change of distance with time. Rate of change of distance with time. For example, if you're given that the distance between point A to point B is 100 kilometers, and a car is driven from point A to point B in 2 hours, then we say that is speed. And speed is calculated by distance covered divided by the time taken. And mostly it is in meters per second. Because distance, the SI unit of distance is meters. And displacement is just the distance in a specific direction. Now we want to look at velocity now. Now velocity, the definition of velocity and speed is the same. The only difference is that now velocity measures the rate of change in distance with time, but in a specific direction. For speed, it can be measured in any direction, but for velocity is now in a specific direction. The next one that we want to look at is acceleration. Now, acceleration is the rate of change of velocity with time. The rate of change, of velocity with time, and it is measured in meters per second squared. It is measured in meters per second squared. Now, today's lesson, we look specifically on relative speed. Now, in linear motion, we have 4 subtopics. We have this topic of speed. We have the subtopic of distance time graph. We have velocity time graph. And then lastly, we have relative speed. And as we have said, we want to look specifically on relative speed. Now, relative speed, it is a measure of speed of 2 different bodies moving either in the same direction or in different directions. For example, if we have point A and point B, and then there's a particle that moves from point A, we have 2 particles. Particle X moves from point A to point B, and particle Y moves from point B to point A. Now, if you are required to find the relative speed of the 2 bodies moving in opposite directions, and then we will add the specific speeds. For example, if X was moving at a speed of 10 kilometers per hour, and then Y is moving at a speed of 20 kilometers per hour, then to find the relative speed of the 2, we're going to add 10 plus 20 to get 30 kilometers per hour. But if you're given 2 particles moving in the same direction, for example, all X and Y were moving from point A to point B, then we are going to subtract the speed of the 2. So the relative speed of bodies moving in the same direction, you subtract the speeds. For bodies moving in different direction, then we are going to add the speeds. We're going to do a few examples to illustrate on relative speed. Example 1. You're given that 2 towns that is Meru and Maua are 80 kilometers apart. Kimathi started cycling from Meru to Maua at 10:00 a.m. at an average speed of 40 kilometers per hour. Mutuma started his journey from Maua to Meru at 10:30 a.m. at an average speed so Mutuma is moving by car. Mutuma is moving by car. By car at an average speed of 60 kilometers per hour. And then the question A, calculate Roman 1, the time taken by Kimathi and Mutuma to meet. This one is given to be 2 marks. Roman 2, the distance from Meru when Kimathi and Mutuma met. Two marks. Part 3, the time of the day when the two met. This is 2 marks. So our viewers, I'm hoping that you have followed the questions and you have written it down so that we can calculate it together. Now we'll start the calculations. Allow me to use this part of the board. The solution to the question. Now first we want to interpret the question. We are given 2 towns, that is Meru and Maua, that is 80 kilometers apart. Let's say we have, because we are told that the linear motion is on a straight line. So this is Meru, then we have Maua, a distance of 80 kilometers. Then we are told that Kimathi started cycling from Meru to Maua. Kimathi is starting from Meru to Maua and is cycling at a speed of 40 kilometers per hour. Is cycling from 10:00 a.m., moving at a speed of 40 kilometers per hour. And then Mutuma started his journey from Maua to Meru. Mutuma is starting from Maua at 10:30, moving at a speed of 60 kilometers per hour. Now the first thing that you need to do is to get the relative distance. Now the relative distance, this is just the distance that separates the two. The relative distance is just the distance that separates Kimathi and Mutuma. For example, Kimathi started a journey at 10:00 a.m. and then Mutuma is starting at 10:30. So there's a distance that is covered by Kimathi before Mutuma left. And that distance will give us the relative distance. Now, the time is half an hour. And the speed, we said that the relative speed is we subtract the two. We subtract the speed of Mutuma and the speed of Kimathi, which is 60 kilometers per hour minus 40 kilometers per hour. That gives us 20 kilometers per hour. The relative distance, the distance that is covered by Kimathi before Mutuma left Maua, which is half an hour. Distance we get by speed multiplied by time, and the speed is 40 kilometers. The time is half an hour, which gives us 20 kilometers. So we have the relative distance, the relative speed. Now what remains now is the relative time. Now the relative time is the time that is going to be taken by the two to meet. The relative distance, if this person has covered 20, let's say the 20 kilometers is here, and we had the whole distance from Meru to Maua was 80 kilometers. So what remains to be covered by the two is 60 kilometers. And that is the relative distance. Now we have the relative distance, we have the relative speed. We can now use the relative speed and the relative distance to find the time that is taken by Kimathi and Mutuma to meet, and that gives us the relative time. Now relative time is distance over the speed. The distance is 60 kilometers. The speed is 20 kilometers per hour. And this gives us, so the relative time is 3 hours. So it means that it is going to take them 3 hours The relative distance here is 60. The relative speed, we said we add the two speeds, we add the two speeds if they are moving in opposite directions, which is 100. So 100, the speed is 100, which gives us now 3 out of 5 hours. So our relative time is 3 over 5. The relative distance is 60. And the relative speed is 100 kilometers per hour. So now we can go to the questions and see which one we can answer. Part A, calculate the time taken by Kimathi and Mutuma to meet. So they took 3 over 5 hours to meet. Now you can change that into minutes. We can change this into minutes. So if you are changing it to minutes, we have 3 over 5 multiplied by 60 minutes to get here 1. Here 12. So they took 36 minutes for them to meet. Now, part 2 of the question, the distance from Meru when Kimathi and Mutuma met. The distance from Meru. Now remember, Kimathi had covered 20 kilometers before Mutuma left Maua. So if you are required to find the distance from Meru, then we will try to find the distance covered for them to meet, and then we add 20 kilometers that was covered by Kimathi before Mutuma left. So first of all, let's find the distance that is covered in the 36 minutes by Kimathi. So distance from Meru is 20 kilometers plus 3/5 hours times 40 kilometers per hour. So you're going to have now 20 kilometers plus, this is 8 kilometers. So 8 times 3 is 24 to give us 44 kilometers from Meru. Now the next part, we are required to find now the time of the day when the two met. Now remember, they are going to take 36 minutes to meet, but Mutuma left at 10:30 a.m. So we'll take the time that Mutuma left, then we add 36 minutes that is taken for them to meet. So we'll take, now we'll have 36 minutes plus 10:30 a.m. to give us 11:06 a.m. as the time of the day when the two met. Now let's do another example that now deals with the same direction, the two moving in the same direction. We have looked at opposite directions. Now we want to look at same directions. So now we want to look at an example now that deals with opposite directions. For example, now we have that A and B are two towns. We have that A and B are two towns. Tom left town A at 8:00 a.m. traveling towards B. Traveling towards B at an average speed of 90 kilometers per hour. At 8:21 a.m. on the same day, James left town B. James left town A for town B at along the same road at an average speed of 97 kilometers per hour. They are required to determine part A, the time James caught up with Tom. Part B, the distance from town A, the distance from town A to the point, distance from town A to the point where James overtook Tom. Part C, we are told that on the same day, Paul left town B for A at 8:40 a.m. traveling, and is traveling at a speed of 80 kilometers per hour. At a speed of 80 kilometers per hour. He met Tom after 2.5 hours. After 2.5 hours. He met Tom after 2.5 hours. Then you're required to determine the distance between A and B. Determine the distance between A and B. So now, first of all, we'll need to find the relative speed of the two, and now the two are moving in the same direction, and we said that when the particles or the bodies are moving in the same direction, then we are going to subtract the two speeds. So we'll subtract the speed of Tom and the speed of James. I told you Tom is traveling at 90, James is traveling at 97 kilometers per hour. So we are going to take 97 kilometers per hour minus 90 kilometers per hour to get 7 kilometers per hour. That is the relative speed. And then we are going to get the relative distance. And the relative distance, that is the distance that is covered by Tom before James left town A. Now remember, Tom left at 8 a.m. and James is leaving at 8:21. So the distance that is covered by Tom in the 21 minutes is what we want to find. Now distance is equals to speed times time. The speed is 90 kilometers per hour times time is 21 out of 60 hours. So we change the 21 minutes into hours. So 3 here, 2, 3. So we have, this is 63 over 2 kilometers, which is similar to 31.5 kilometers, and that is the relative distance. Then now we'll find the relative time. We want the relative time. Now relative time, we will use now the speed and the distance that is here. Now time is equals to distance over speed, and the distance is 31.5 over speed, which is 7 kilometers per hour. We'll rub here so that we can continue from this end. So we have our relative time is 31.5 kilometers divided by 7 kilometers per hour. And that, if you divide, you're going to get, you'll get 4.5 hours. That is our relative time. So the first question reads, the time James caught up with Tom. So the time that James caught up with Tom, James left at 8:21 a.m. and they are going to take 4.5 hours, 4 hours, 30 minutes. So we'll add to this. So 8:21 plus 4 hours, 30 minutes is 12:51 p.m. Part B, the distance from town A to the point where James overtook Tom. Now the distance from town A to the point where James overtook Tom, we will find the distance that is covered by Tom. So James is leaving at 8:21 and it's taking him 4.5 hours to overtake Tom. So distance is equals to speed times time. The speed of James is 97 kilometers per hour. The time that it took to overtake Tom is 4.5 hours. Then now we find this is 97 kilometers per hour times 9/2 to give us 436.5 kilometers as the distance that was covered, as the distance from town A to the point where James overtook Tom. Now the last part that we want to look at is on the same day Paul left town B for A at 8:40 a.m., traveling at a speed of 80 kilometers per hour. He met Tom after 2.5 hours. We are required to define the time, the distance between town A and town B. Now, first of all, we need to find Now the distance that is covered by Tom from 8 a.m. up to 8:40. Remember, Tom left at 8 a.m. Now distance covered by Tom from 8 a.m. to 8:40 a.m. So from 8 a.m., remember these are 40 minutes and is moving at a speed of 90. So it is 40 out of 16 hours times 97, 90 kilometers per hour. And that will give us 60 kilometers. That is the distance covered by Tom from 8 a.m. to 8:40 a.m. Now, we want to find now the distance that is covered by Paul. Remember, Paul is coming from town B to town A, and James is coming from town A to town B. So let's say we have town A to B. We have Tom. We have Paul. He left at 8 a.m. is leaving at 8:40 a.m. In the 40 minutes up to 8:40, this person has covered 60 kilometers. And remember, they are taking 2.5 hours to meet. So it means that Tom is using 2.5 hours, Paul is using 2.5 hours, and they're going to meet somewhere. So what is the distance covered by Tom in the 2.5 hours? In 2.5 hours. So that is 90 kilometers per hour multiplied by 5/2. This is 45. 45 times 5 is 200 kilometers. Not 40, 45 times 5, this is 5, carry 2, it is 225. 225 kilometers. And Paul is also moving from town B. So distance covered by Tom in 2.5 in 2.5 hours. That will be the speed of Tom was 80 kilometers. So 80 kilometers per hour times 5/2 hours. So here 1, here 40. That is 200 kilometers. So the total distance from town A to town B will add 60 plus 225 plus 200. 60 plus 225 plus 200 to give us that is 225 plus 200 plus 60 to give us 485. So the distance between town A to town B is 485 kilometers. So I hope that you have seen how to deal with the relative speed and how to do the calculations that involves the different directions, two bodies moving from opposite directions and two bodies moving in the same direction. And we have said that for the bodies that are moving in the same direction, you are going to subtract the speed to get the relative speeds. For the bodies that are moving in opposite directions, then you are going to add the speeds to get the relative speed. And you can now use the relative speed to get the relative distance and to get the relative time. And after getting the 3, you can now calculate any of the variables that are required to be calculated. Now, in conclusion, all that we have discussed today is to deal with relative speed that is under linear motion. And I'm going to give one last question that you can attempt during your free time to at least try to apply what we have learned today. I'll give a question, one question that you can try to apply to see how to deal with relative speed. Now the question is, a bus left Nairobi at 7 a.m. A bus left Nairobi at 7 a.m. and traveled at a speed of 80 kilometers per hour. At 7:45 a.m., a car left Eldoret towards Nairobi at a speed of 120 kilometers per hour. The distance between Nairobi and Eldoret is 300 kilometers. And then calculate part 1, the time the bus met the car. The bus met the car. And that is 4 marks. Part 2, the time the bus arrived at Eldoret. The time the bus arrived at Eldoret. Part 3, the distance of the bus from Eldoret. The distance of the bus from Eldoret, the distance of the bus from Eldoret when the car arrived in Nairobi. That is 2 marks. And then lastly, part 4 is the distance from Nairobi when the two met. The distance from Nairobi when the two met. is also 2 marks. So you can attempt the question, write the question down and attempt it, and you can try to see if you have the right answer. You can see if you can get the right answer from that question. I'm giving a few minutes to write it down. Now, this relative speed can be applied in various occasions. It can be applied by a driver that wants to overtake a car that is in front, and also to try to see how long you need to travel or how fast you need to travel to catch up with a car that is in front. Let's say there's a police chase, and a police car needs to catch up with a car that is in front of it. Then they need to use this relative speed to calculate at what speed that they need to move so that they can catch up with the car that they're chasing. And other areas that it can be applied in real life situations. I'm hoping that you have written down the question and use the time that you have to calculate it. And we are coming to the end of our lesson. Thank you for watching, and thank you for listening, and also for following up the lesson till the end. And thank you for tuning in to Kenya's #1 premier educational channel, KUTV. I was your host, Teacher John Otieno. Till next time, I wish you all the best until we meet again in another lesson, another time. Thank you.